if I had, let's just say I had A as being equal to 3 and B as being equal to 2. Okay, well, that's a terrible 2. What you can do is you can display, like, let's just say it was display A equals B. Okay, this would output, why is this not, there we go. This would output, because A is not equal to B, false. Okay, this would be the output right here. I try to put the output like in a box just so you can kind of see it. Okay. But if I were to do A is not equal to B, now it would be true. It would output true. Okay. Any of these things right here are basically asking you, is A equal to B? Is A not equal to B? Is A greater than B, less than B, greater than or equal to, or less than or equal to? So you just have to basically do a little bit of math in your head. Is 3 greater than 2? Yes. So then it would print out true. Okay. And it's all based on the whatever operator you have right here. Okay. So act like we had a, let's act like we had a less than. Is A less than B? So I'm just going to get rid of this here. Is A less than B? No. So it would say false. That's basically how that works. And you can do less than, greater than, whatever you want to do. Okay. Let's go over the next one here. Let's get rid of all this. Embarrassing. All right. Let's do this. Okay. B. All right, for the not, so this is a not keywords or not operator. Basically, it just does the opposite of whatever you're looking at. So say you did something like not, I did not 3 is greater than 2, okay? This right here, this 3 is greater than 2, is technically true. So then it would be not true. Well, not true is false. So then the answer for this one would be false. Now, I did not do a display on here, so this is kind of embarrassing, but you want to have a display here around this whole thing. Okay, otherwise it would not actually display the false. The computer knows it's false, but it's not actually telling you, the user, that it's false. Okay, as a programmer, you're going to pick and choose what you want to be displayed on the screen. Okay, there's a lot of background noise going on when anytime you run a program, you don't necessarily want to see all of that. You just want to see, you know, whatever game you're playing or whatever app you're using, that sort of thing. But that's basically what the not does. It does the opposite of whatever's there. Okay, and if you notice it right here, it kind of says that. It says right here, it says evaluates true if condition is false, otherwise evaluates false. Okay, so the otherwise means the opposite. So if it's true, if you do not true, it's going to be false. If you do not false, it's going to be true. Okay, it's just the opposite. Questions on that? Okay, very, very, very basic thing. Go ahead. Yeah, I can hear you.
What would the point of doing that be? Like if something's false and you say it's false, like what would you kind of use that for?
I always use the example of a self-driving car, but it's just like if not people around or something like that. You might have a people around sensor, like if there's like sensing people or sensing objects or something like that. If not, then you can keep driving or something like that. It's just like a straight up logic. It's kind of like, well, when do you use not in your head? You know what I mean? If it's not 7 a.m., then go back to sleep. You know what I mean?
Yeah.
So it's kind of that sort of thing. Now, we're not going to get into sensing time. I mean, we could, but it's not part of the class. But you can actually like sense time. If not blank time, then whatever. If not blank color, then whatever. So it's like, it's because sometimes it's easier to say not than all the other possibilities. Okay, like say you have all these colors, rather than saying if it's, you know, red, orange, green, and purple, then do this. You could just say if it's not blue, then it's all the other colors. You don't have to worry about which ones it is and which ones it isn't. You can go your whole life never using not. I mean, some of this stuff is more obscure, like you won't necessarily use it, but I still have to teach it because it's part of the curriculum. So, but you're right, yeah. Like you're probably thinking, when would I need this? I could just do true and false each time. But
yeah, all right, thank you.
Oh, yeah, no problem. And again, even if you are not interested in computer science, like this is for the whole class, if you're not interested in it, it's still good thinking. You're still thinking like, what would, like, you're breaking down your thoughts and like kind of how like I wrote it here. So it's still good thinking exercises just from a logical standpoint. Let's go over the and. This next one is the and keyword right here, and. With and, for it to be true, they both have to be true, okay? So, for example, true and true would yield true, okay? If I was going to display this, which I forgot to write display again, display this would display true, okay? Because true and true is true. Okay, this would display true. But if you did true and false, then it would be false. You would just say false. Okay? Basically, one rotten apple spoils the bunch. If you did false and false, that's still false. Okay? What I'm gonna show you here, it's called a logic table, or truth table sometimes they're called. So say you had let's just say we had one input and you had another input. So input 1 and input 2. Oops. That's embarrassing, trying to get it to be a straight line. All right, if you had true and true, the output for this would be true. This is with its and. So I should write and here. This is an output if it's an and. All right, if you did true and false, or false and true, they're both going to be false. And then if you did false and false, whoops. If you did false and false, let's put this line here, you would also get a false. Okay. So this is an and output. Okay, the last thing is or. Okay. This is also it's called an inclusive or. Okay. Sometimes most people use ors exclusively. They're like, do you want to go to Taco Bell or McDonald's? It's one or the other. That's called an exclusive or. Ors in programming is, in this case, this or is inclusive. Okay, which means like if someone said, do you want to go to Taco Bell or McDonald's? You could say yes, meaning you want to go to both of them, right? Or I guess you could even say yes and to go to either one of them. But or could be both one or the other. Okay, and I'm going to show you the truth table will help with this. So I'm going to do an or truth table. So here's input 1, here's input 2, here's the output with or. Okay, so I'm going to make a table really quick. Put this over here like that. Okay, let's just do true or true. Again, it could be either or of them or both. So either way, it just ends up being a true. Okay, true or false is still a true because at least there's one true in there. Okay, if you compare that to and, it has to be both. They both have to be true. For this one, as long as one of them is true. So false true would still be a true. And then false false would be a false because there's no trues in there. Okay. That is an or. There are things called Xors, again, which is exclusive or. It has to be one or the other. It can't be both. So an XOR, don't write this down, but if an XOR, you'd put an X there, and then this would be a false because it's not one or the other. But we don't need to worry about that, so ignore. It's called an inclusive or. It could be both. Okay, that is all about relational and Boolean operators. So you have to know that it spits out a true or false with any of these. You have to know the not is just the opposite, and you have to know the and the or. There's also a NAND and a NOR. NAND means not and. You probably already know what NOR means because it's an actual word, N-O-R. It means not or. Okay, you know what I mean? Like, I am gonna neither go to the store nor Taco Bell. I don't know why I always use Taco Bell as an example, but like nor, you've probably heard of the term nor before. We're not gonna worry about that. It's not part of the curriculum. So, but there are NANDs and NORs. It's kind of cool.